Yeah. All right, so we're going to finish this today. 5.2 will be due tomorrow, and your quiz will be tomorrow, too. I think it's like 3 questions. All right, so number 1, these are all properties of definite integrals, all right? Different things that when you step up to a problem, different things, different techniques that you can do to come up with the answer. All right, so if you are taking the integral from a to a, okay, so that means that your lower bound and your upper bound are the same number. That means that your answer is 0, right? So think of it as if I start here and I don't move, I haven't gained really anything, okay? And think of it as also like if you're finding the area of something but it doesn't have a width, again, your area would be, your answer would be 0. So if you did like 2 to 2 of x squared plus 6x dx, right, the upper and the lower bounds are the same. So they are just 0. All right, we've already kind of talked about number 2, right? If I go from A to B, I can switch that around if I put a negative out front. That will also give me the same answer. Right, so if I'm taking the area going from A to B and that's positive, right, if I switch it, if I go from B to A, it'll be negative, and then if the negative's out front, now makes it positive again, right? So all these are going to help you kind of simplify different equations. If you have just a constant, so that's what the C stands for, constant. All right, essentially what you're doing is you have a horizontal line and you're trying to figure out the area that the rectangle makes, right? So if this was like 1 and this was like 10, you figure out a rectangle going from 1 to 10 of however tall that number is. 4 is pretty self-explanatory. If you have one function plus another one, or one function minus another one, you can split them up. All right, so you can take just the first one, evaluate it, and then take the second one and then add or subtract them depending on the problem. All right, if you have, say, the integral of, again, another constant being multiplied to a function, what I can do is I can put that constant out front, all right, and then I can integrate just this part here, and once I get that answer, I can then multiply it by whatever my constant was. So if I had, say, 2 over x dx from 1 to 4, right? What would my constant be that I could put out front? 2, right? All right, so I have 1 to 4 of 1 over x dx. Right, so the antiderivative of 1 over x would be what? Right. And then you would evaluate it going from 4 and then to 1. So this is kind of like what the next section helps us do. Right, so you're finding the antiderivative and then answering it from 1 to 4. But again, kind of getting the practice of putting those constants out front because it'll make it easier to find the antiderivative. And then the last one, if we have 2 integral expressions and I want to move it down to 1, you have to make sure that the upper bound here and the lower bound for here have to be the same number. So when you then push them together, that'll be same thing as going from here to there. Right? So they have to be the same number. And usually it has to be between those two numbers there. Right. All right, number 11 says the integral from 0 to 10 of f of x is 17. From 0 to 8, it's 12. Figure out 8 to 10 of 3 times f of x plus 2. Okay, so what does that mean? We have a constant here, right? So I can put the constant out front, and then you have one function added to another. So you can split that, what you have in parentheses, up into two separate integrals. So my first one would be 3 integral from 8 to 10 of f of x plus the integral from 8 to 10 of 2 dx. We go with that? Okay, now, do they give us what the integral is of just 8 to 10 of f of x? No, right? They give us 0 to 10 and then 0 to 8. So we have to now figure out a way that I can put the two of those together so that I can come up with 0 to 8. Okay. So what would that turn into? So what I want to do is I want to write this, instead of it having it be one integral, I want to write it as two different ones. So like instead of one, I want to make now two integral expressions. So in order for me to be able to put those two together, the upper and the lower have to be the same thing. Right? So I want to start with 8, right? Right? That's what I'm looking for here, starting with 8. So 8 needs to be my lower bound for my first integral. Right? So I'm not going to use this one because it doesn't have 8, right? And then I got to use this one, but it starts with 0. But what can I do with the switch it, right? So I can make this 8 to 0 of f of x dx, and what would that become? Not 1 over. If I'm going from 0 to 8, and it gave me 12, if I work backwards, it'll give me, right. Okay. And then, so if I have 8 to 0, right, and then what would I be able to add on to that? What second integral expression? Good. 0 to 10 of f of x dx, and we know that that is 17, right? So if I put them together, what is 8 to 10 going to give me? Five, right? All right, so I can split this up so that I have eight to 0 of f of x plus 0 to 10 . So 8 to 10 of 2. All right, so by taking these two expressions, these two things are now equal to that, right? The upper and the lower here match. So if you push them together, you're really going from 8 to 10, which is what we want. So we know that this is negative 12, and we know that that is 17. So together, they are 5. And this constant that you put out front just kind of goes along for the ride until the problem gets over with. Now, when you do the integral expression of 2 from 8 to 10, all right, imagine again you have a horizontal line there at 2, and you're looking at it from 8 to 10. So it's kind of like a rectangle like that. So what would your area be of that? 4, right? That's 2, and that's 2, right? Another way you can do it is if you can just take 10 minus 8, right? You get 2, multiply it by the function or the constant that you have, and that's 4. And we know that the original was 15, so my answer, 19. That's it. Yeah, if you have just a constant and they give you a definite integral, yeah, you can just do that. It equals 8 to 10, not 0 to 10. Right, right. So they originally said from 0 to 8, it's 12, right? So as you go from left to right, it's 12, right? If we switch that, right, now we're working backwards. We're going from right to left. So now that it is, when you work from right to left, any positive regions now become negative. So it's like opposite. Because like if you are, if we say we started at 8, went back to 0, and then went back up to 10, it's the same thing if we just went from 8 to 10. Like you're kind of cutting out the middleman, and you're just going from, instead of having starting, stopping, starting, and stopping, you can just go from start to the end. Instead of like, you know, when you fly across country, you usually have to like stop somewhere. This is like, this would be just like a direct flight. This would be like, you have to stop somewhere and then get on a new plane and then go over again. Right, so if you did like, if you did the integral from like 10 to 0, what would that be? What is it, what do they tell you it is from 0 to 10? So if you go from 10 to 0, negative 17, right? It's just opposite. Right? And then in order for to take two integral expressions to make one, you just have to make sure that this number is the same as that. Well, you have to use like what they give you. You can't just like pick whatever number you want. Yes. Yeah, so you could have done 0 to 8 and then put a negative out front. It's the same thing as doing this. Okay. Last one says, if the integral from 0 to pi of sine of x dx is 2, use this fact and symmetry of the graph to find the following. Okay, so normally sine has a period of what? Like how long does it take to do one full 2 pi, right? So this would be 2 pi. All right, so they're saying that from 0 to pi, which is right there, your answer would be 2. Do you see that? No. Right, so if the area from 0 to pi is 2, what would the area be from pi to 2 pi? 2, right? Because it's symmetric. And then if I did the area from, say this is negative pi, right? What would the area be from negative pi to 0? 2 again, right? So they're all symmetric. So we want to use that fact to help us answer those questions. All right, so pi to 2 pi would be what? Negative 2, right? It's underneath the x-axis, so it's got to be negative. What about 0 to 2 pi? 0, good. So if you go from 0 to pi, you get 2, and then pi to 2 pi is negative 2. So if you put them together, you get 0. All right, pi to pi halves. So pi is there, pi halves would be here. Right, and pi halves is half of pi, right? So if the whole thing here from 0 to pi is 2, half of it would be what? 1, right? That would be 1, that would be 1. So if I'm going from pi to pi halves, my answer would be negative 1, right? Because you're working backwards. Yes. It would be positive. No, Sam asked if we did from 2 pi to pi, what would the answer be? And that's what you asked too. So normally if we did it from pi to 2 pi, it would be negative 2. But if I'm going from 2 pi to pi, this now, as I go from right to left, this now becomes positive. So this would be positive. Okay. 2 plus sine of x. So again, get in the habit of splitting those things up. So what would 0 to pi be, or 0 to pi of 2? What would that be? So you have 2 times pi minus 0, right? Upper bound minus the lower bound. And then we know that the integral from 0 to pi of sine of x would be what? They already gave us that. 2. Yep. So my answer would be 2 pi plus 2. So that's a constant, right? Right? So I can, if I have a constant, right, all I can do is I can take the upper bound and subtract the lower bound, right, and then just distribute. Yeah. Yeah, if you have just a constant, you can do that. What do you mean 2? Zero to pi. Right. So 2 pi, you really can't put 2 pi plus 2 without a calculator. So. Yeah, this here goes with that. Here. What, no. You have like. Right, it's like you have a horizontal line there at 2, and you're looking at it from 0 to pi. So your base would be pi, and your height would be 2. So 2 pi. All right, what can I do with letter E? put it out front, right? So I know from 0 to pi, it is 2, right? And then I have that 2 out front. So my answer would be 4. What would it be from negative pi to pi? 0. Good. 0 to pi of cosine of x. So I'm going to call that pi, 2 pi. Good. Is that right? There we go. What are we looking at? We're looking at this is pi halves, right? Okay, so if I'm looking at it from 0 to pi, right, this region should be the same as that, right? So whatever I gain, I then lose, right? So 0 to pi would be 0. And then 0 to 2 pi would be what? Would also be 0, right? Right, so imagine this is like positive 1, negative 1, now you're at 0, negative 1, now you're at negative 1, you add another 1, now you're back to 0.